This is a tutorial on serialization in Java. To tackle this tutorial, it's good if you already know not only lots of basic Java, but also how to read and write text files in Java, because we're going to kind of build on that here. So if you've seen my previous tutorials, we've already covered reading and writing text files. Another thing that I'm going to use here is I'm going to use the try with resources syntax that was introduced in Java 7. So I'm going to read and write files in this tutorial using a Java 7 syntax, which I've also covered in a previous tutorial. And if you're using Java 6, you'll need to use a slightly different form of exception handling, a kind of old version, which you can find again in previous tutorials that I've created on reading and writing files. So with those caveats, let's proceed. Now I've already created a project in Eclipse here, and I've created a few files. Serialization, I should say, what it is if you take an object and you serialize it, it means turning that object into a kind of binary form, into binary data. And if you deserialize an object, it means taking binary data and turning it back into an object. And what we're going to look at here is serializing to files. So, which is often what people mean when they say serializing in Java. So we're going to take objects of this person class that I've created, and we're going to write them to a file, and then we're going to see how we can read them back from that file. So taking the objects out of the file and turning them back into objects in a Java program. Now normally this would be both of those, reading and writing, will be part of the same program. So if you have a program with, let's say, a open facility and a save facility, then you could implement those if you wanted using serialization. But rather than create a whole massive GUI program or some kind of menu system here, to demonstrate serialization, I've got two separate programs. I've got one main method here in this read objects class, and I've got a different main method in a write objects class. So what I'm going to do is I'm going to create one little program that writes objects to a file and another program that reads them from the file. But bear in mind that normally reading and writing will be part of the same program. And of course in Java you can happily have more than one main method in your program, even though you've then got to pick one main method as the starting point for your program when you actually run it. But you're allowed to define as many main methods as you want. And it's not uncommon to have a Java program that will have more than one main method, because you might, for example, have your normal entry point of your program, and you might have like a test main method that tests stuff as well, for example. So we're going to make use of that here. And what I've got here is, firstly, I've got this person class that I've created, and it's just a really simple class. Again, building on previous knowledge that I hope you've absorbed by now. We've got a simple person class with just some simple data, an ID and a name. We've got a constructor that allows us to set that data, and I've given it a two-string method, so that if we call system.out.println and pass it a person object of this class, it will display in a kind of nice way. I've got a write objects program here, and what this is doing at the moment is it just says writing objects. It creates an object, well, it creates two objects of the person class with different IDs and different names, and then it's just using sysout to display those objects. So if I run that, we get this down here, and I've got this read objects program, and all this is doing at the moment is it just displays the text reading objects but doesn't do anything more. So first let's concentrate on writing our objects to a file. So I'm going to take these two objects here, two little simple objects with some data in them, and write them out to a file. Now to do that, I'm going to use a class called file output stream. Let's call that fs and set that equal to a new file output stream. And this class lets us stream data to a file, as you might expect. Streaming just means kind of sending data sequentially to a file. So we need to supply an argument to the constructor here, which is the name of the file to stream to. And I could supply a full file path here, but what I'll do is I'll just give it a simple name. Let's call it people.bin. The extension doesn't matter, you can call it what you want, but .bin or .dat are typical for binary files. It could be anything and all though. And if I just give a name without a full path, then we'll write that to the working directory of this program. And the working directory, if I run it in Eclipse here, will be the project folder here. So I'll be able to see it down here. In fact, here's one I created, here's one I created earlier. Let's go back to Eclipse. And I'm just going to delete that now because I want to create it from scratch. Okay, so let's import file output stream. So I'll click this warning, this error here, and go to import file output stream. And now the second thing we've got to do is handle the exceptions. And at this point, you could go to surround with try catch, or even add throws declaration and throw the exception out of your main method. What I'm going to do is use Java 7 syntax, the try with resources that I described in a previous tutorial. I'm going to type try here and surround the whole thing, getting rid of the semicolon with brackets, and then put the curly brackets in. And then if I click the warning, I can go to add catch clause, and we can catch the exceptions that this throws. And the advantage, as I described previously in a previous tutorial of try with resources, is that this syntax will automatically call the close method of this object. So it's going to call fs.close. If you use a kind of Java 6 or before type try catch block, you need to remember to call fs.close later on in your program. It's really important, but here it will be called automatically if I put it all in the try block like that. It's just that this is only possible in Java 7 or later. Okay, so now this will catch a file not found exception, which I guess will be called if we can't create this file. And IO exception can be thrown as well, and that is going to be thrown if we can't write to this file for some reason. So if you're going to write a robust program to distribute to end users, you need to of course handle these exceptions gracefully by popping up an alert or outputting a message or something. But here I'll just leave the stat trace in because I just want to demonstrate the principle here. So we've got a file output stream, and the next thing we need is object output stream, which I'll call OS. I'll set that equal to a new object output stream, and we need to pass to the constructor of that the file output stream object that we're going to use to allow this object output stream to stream data to our file here. Let's add the import by clicking the error and going to import object output stream. Now here I need to call the close method myself. Let's say os.close of this object output stream, otherwise I'll get a warning there. I feel that there must be a more elegant way of dealing with this, of dealing with the exceptions here and of closing things, but this is the most elegant way that I can figure out, so we'll stick with it here. At least it works, but it just kind of annoys me that this is being closed automatically and this isn't. But I don't want to start nesting exceptions. I personally really hate that. It looks so ugly. So at least we've not got any nested exceptions here. We just have to call close ourselves on this, even though the close method is being called automatically for this one. But anyway, so pretty simple. And if you're used to writing text files, you'll recognize this syntax. We're just kind of taking some kind of output stream and passing it some kind of file output stream and using that to write to a file, kind of a Russian doll type thing with one object being passed to another. Now we can use this object output stream to write these objects to a file. So in between, obviously in between opening it and closing it, so here we can say os.write, and if I type write, you can see in the autocomplete that we've got methods for writing all kinds of stuff here, all kinds of data, like write char and write double and so on. You can write whatever data and objects you like to your file. You can serialize whatever data you want. You just do it sequentially. And here what I'm going to do is I'm just going to serialize these two objects one after the other. But there's no problem in mixing different objects. Or you could write objects and your own custom objects and write integers or strings or whatever you like. You just do it one after the other. So you can serialize whatever you like here. Let's say because I want to write an object of a type that I've declared, I'm going to use the write object method here, and I'm going to pass it one of my objects. So I've got this object, the variable's called Mike, and it contains the data, this ID and this name. And once we've written that, let's write another one. Let's say os.write object, and let's write my Sue object, so this one here. And that is enough to serialize the object to a file, except for one important thing. If I run this now, what we'll get is a not serializable exception, and it's mentioning my class here, which I call person. Now there's this kind of classic interview question, or job interview question, or exam question. How do you make a class serializable in Java? And the answer is very simple in a way. So I'll go to my class here. I want to make this class serializable. In other words, I want to make it possible to serialize this class, just like I can serialize strings and doubles and all that sort of thing. All I have to do is implement the serializable interface. So how do you make an object, how do you make a class serializable? Implement the serializable interface. So I just need to type here implements serializable, and whoops, I need the E there, and I need to import serializable, capital S, because it's the name of an interface, and interfaces and classes always start with a capital letter in Java. And now, hey presto, we can hopefully do this. Let's run it. So notice the interface doesn't have any methods in it. All we've got to do is just say that we implement it, and we don't have to do anything else there. And if I run this, well, let's select write objects and click run. And now, hopefully, well, we haven't got an error, so hopefully we've written that file. And because I wrote it to my working directory of my program, just with a simple file name, now if I click on a project, right click and go to refresh in Eclipse, it should appear down here, is people.bin. I don't know what that is. I think that's something that was created earlier, maybe. I'm not really sure, but I'll delete it anyway, because this is what we're interested in. So we've written that file, we've written two objects to that file, and now let's write some code that can read those objects. So I'll go to this read objects little program here, and now we want a file input stream instead of file output stream. So file input stream, I'll call it fi equals new file input stream. So again, I need to pass it the name of the file that I want to read from now, which is again people.bin. And let's surround with try again, using this Java 7 try with resources syntax, which will close this automatically. And I'll import the class, and I'll add the catch clauses. Here we go. So again, file not found for if the file isn't found, an IO exception, input output exception for if there's a problem reading from the file. And again, if you use a different exception handling syntax, an older style, you must call fi.close. Don't forget to do that. And now I'm going to create an object input stream, as you might guess, object input stream instead of object output stream like we had previously. Let's call that OS and set that equal to a new object input stream, and pass in the file input stream there. Don't forget to call os.close like that, and let's add the import, and let's save that. So this looks fine, and now I can read from my file. So let's we're going to have a we know that we wrote two people objects, so we're going to read two person objects one after the other. Let's say person1 equals os.read object, and because this returns a object, the kind of grandparent object class, I need to cast this to the actual particular object that it is, particular type of object, which is person. And this also, if we look at this error now, this throws another exception. So let's click on that and go to add catch clause. So we'll catch another exception down here. And what this is as you can see, you can read your object in a different program to the one that to the one that wrote it if you want to, although that's not typical, but we are doing here. And that means that read object might read a object of a class that doesn't even exist in this program. And if that happens, it's going to throw class not found exception. As it happens here, we do have the person class defined in this program. I've got my main methods all in the same default package here, so there's no problem. But this will be thrown if you try to read something from a file and you don't even have that class defined in your program. Let's read our second object. So person2 equals, put the typecast in, and then os.read object, and save that. And just to show that we've read those correctly, let's go down here and put in sysout person1 and sysout person2 and save this, and let's run it. So let's go to, make sure we're on read objects and click run. And now we can see it says reading objects, and then we've displayed our people, and we've got the objects that we wrote, Mike and Sue. And of course we've got them, we've read them in the same order that we originally wrote them in here. So you can use this to implement saving and loading functionality in your programs, which is quite handy. I'm just gonna, I want to show you one other little thing. You may have noticed, if you've been doing a lot of programming in Java, that sometimes you get this warning in Eclipse, and I'm not sure whether this is coming from Eclipse or from the Java compiler, but it says the serializable class person, in this case, does not declare a static final serial version UID field of type long. And to get that warning to go away, you can click on it, and you could go to add default serial version UID, but let's go to add generated serial version UID. And what it does is it just adds this static long field that's set to basically some random number. And if you just want that warning to go away, then you can just do that and forget about it. But what actually is this? Well, let's take a look. If I go to write objects, and we'll run it. So I'm writing objects. I'm writing my person objects to this file. Actually, I'm overwriting the original objects now, so I'm writing them again. And they've got this serial version UID. Now let's change this serial version UID to, like, I'll just change the 4 to a 3 at the beginning, save it. And let's run read objects here. So I'll run this, and it says, gives me an error. It says, invalid class exception, and we've got some stuff complaining about how we tried to read with this serial version UID, but they were written with this serial version UID. And indeed, if I change this back to a 4 now and run my read program again, read objects, then it reads fine. So all this is it's an ID that in order to deserialize objects that you've previously serialized, in other words, in order to read objects from a file that you've previously written to the file, if they've got this defined, then it must match the class that you wrote with, must match the class that you read with, or vice versa, I should say. You must read with a class that has the same serial version UID if it was defined to start with. And all that is a way of checking that you're reading with the exact same class that you wrote with. So you could write to a file, and then years later you try to use a different version of the program to read from that file. And if the class has changed a lot, if it's changed significantly at all, in fact, since the last version, you would change this serial version UID, and that's one way of saying, look, this class is different. You can't read this file with this version of the program anymore. So by changing that, it means that you can no longer use the new version of the class to read from the file because it's just changed too much. So if you added more IDs or deleted these or something, you could change this to stop people trying to read with that new version of your class. And as far as I know, that's really all it's for. Maybe not a tremendous lot of use, but it gives you a way of checking that you're reading with the same class that you wrote with. And that's all there is to it. So I'll leave it there for this tutorial. A lot of stuff in one tutorial, and if you're a bit lost, then you might want to go back and check some of the basics, like this try with resources, reading and writing files, and possibly defining classes and stuff like that. But if you followed it, congratulations. And this is one of the most complicated things that you'll find in like the really sort of core of Java, and it's a popular topic on exams and job interviews as well.